Hello everyone, welcome back to another episode of Tantra's Mantra where we go behind and beyond the tech news headlines. I am Prakash Sangam, your host and founder of Tantra Analyst. I am back with another episode today looking at the 5G infrastructure space. As you may know, Intel made a major announcement a few days ago at an event they called How Wonderful Gets Done. Interesting name. This announcement was about their latest third generation Xeon Scalable processors. One of the key emerging application I would say for these processors is 5G networking. That includes both core and radio networks as well as edge cloud. We have with us today Jeni Panhorst VP and GM of Network and Edge Platforms at Intel to discuss the challenges of networking and edge cloud deployment specifically and how the latest Xeon processors will help in solving those challenges. Jenny, welcome to the show.
Thanks, Prakash. It's great to be here to talk about how wonderful gets done in the network and edge.
Excellent. Very excited to have you here. Could you please give our listeners a quick overview of your background? I think you've been with Intel for more than 20 years. It's a long time. Would love to hear about your journey in the company as well.
Yeah, absolutely. Yeah, as you said, I've been with Intel for actually going on almost 22 years now, and it's been really exciting. I've spent really all of my time focused in parts of the business, including embedded IoT communications and networking, that are really all about taking the power of Intel technology and applying them to new markets. And particularly in the networking space, I've been a part of this journey with Intel from the beginning, growing the business quite considerably over the course of well over a decade. And it's been really exciting to be part of the transformation that Intel's been able to have a hand in now where we are today in this exciting space on the precipice of both 5G and edge rolling out in great scale.
Very well. Thanks for again coming over onto Tantra's Mantra. Let's get started. Let's start with congratulations on an excellent announcement. Could you let us know how important these third gen Xeon processors are for specifically 5G networking market, especially vRAN and edge cloud deployments?
Yeah, we're really excited about the announcement this week. Not just what it means for Intel, but what it means for all of the customers and the partners and the markets that we serve. And if you look at what the third generation Intel Scalable Xeon processors and also the other platform ingredients that we launched have the capability to deliver, it's really about the combination of flexibility and performance to help our customers achieve more, to help our customers do wonderful, to use the tagline. And when you look at all of the workloads that we focus on across the full data center space, inclusive of networking and edge, we're seeing over our prior generation, our second gen processors, over a 46% improvement across a number of different workloads. And so then when you kind of take a click down and look at the capabilities of these processors and what they're able to deliver when they're paired up with other technologies and products like our FPGA portfolio, our Ethernet portfolio, our Optane persistent memory, and then many other software capabilities like FlexRAN and openness and Visual Cloud and Intel Smart Edge. These third gen Intel Scalable processors are really focused on empowering our customers with a balanced architecture focused on key capabilities that we're delivering in AI acceleration and in security, and really enabling a number of key workloads all the way from edge to cloud. And so obviously, you want to talk a bit about the network. So do I, of course, given where we focus. And so if we take a look at what third gen is able to do for vRAN, what we're seeing is that compared to the prior generation processor, we're able to see 2x massive MIMO throughput in the same power envelope. And this particular benchmark is based on a configuration of 3 by 100 megahertz sector 64T 64R. So huge improvements for operators in deploying their 5G networks. But of course, we need a 5G core backing that 5G RAN. And so if you look at the types of performance gains that operators are able to see in 5G UPF deployments, they're seeing over a 40% performance increase increase generation on generation. And really, that's a combination of not just the processing technology, but also the Ethernet connectivity that's paired with it in order to deliver high performance for specialized protocols that are so critical to process in 5G core. And if you look at today's networks, Xeon really is already the basis for most 4G and 5G core deployments, as well as all known vRAN deployments that are out there today. So we're really looking forward to what 3rd-Gen Xeon Scalable will do in playing a crucial role in the future.
Very well. So especially the 3 to 100 megahertz and 64 to 64R support, I think that is very crucial for operators. With 5G going great guns, traffic going through the roof,
Yeah.
they'll need all the benefits that they can get in terms of increasing capacity in the networks and so on. Perfect. So in terms of solutions themselves, if you take the 3rd-Gen Xeon Scalable as an example,
Mm-hmm.
how much effort do you put in making a solution looking at the needs of the legacy networks versus new architectures like vRAN? Is that different? Is the same? If different, how different, and how much is it different?
Yeah, it's actually you learn a lot from having solutions coexist. You get to actually apply learnings from one domain to the other. But for us, we're focused on both. It's definitely a both and type of situation to be able to address the fact that you are going to have traditional RAN and virtualized RAN coexist over some time to come. And you also need to make sure that those deployments that are in existence can also operate seamlessly with one another. And so it is important for us to have really a bead on both of those and understand exactly how the solutions are build and partner across the ecosystem to make that happen. So we are focused in both domains. If you look at specifically the role we've been playing in the traditional base station market, one announcement we made earlier this year is that Intel was able to achieve over 40% market segment share, number one market segment share in the base station market, which is actually 2 years ahead of our original goal. So we've been making pretty considerable investments in the base station space over the course of the past several years to ensure that we can enable telecom equipment manufacturers and the operators who deploy those solutions with best-in-class capabilities to be able to continue to grow and roll out 5G capabilities. And this will continue to be a huge area of investment for the market. If you look over the course of the next 5 years or so, over $200 billion of investment is forecasted by various analysts in continuing to roll out traditional RAN solutions. And I mentioned before, though, vRAN is obviously coming on very strong. And so when you look at the growth rate of vRAN by comparison to traditional RAN solutions, vRAN's projected to grow at a CAGR of over 60% over the course of the next 4 to 5 years. And so for us, it's really important that we focus on both where, the majority of the market is today, but then also where the majority of the growth is coming from. So you asked about, how is it that we invest in each of these spaces? For, traditional RAN, it includes investments in base station specific technologies. We have base station optimized SoCs like our Atom P5900 product line, which we launched last year, which I think you're aware of. And also pairing those solutions with, custom and segment specific silicon solutions, and then also pairing them with specialized software in order to create full solutions. And some of those custom silicon solutions come from our FPGA and our eASIC technology, but it's important that, we're able to partner with the telecom equipment manufacturers to bring those together into solutions. For vRAN, by contrast, we're focused on really server-based and standards-based building blocks. And so for us, it really is about emphasizing Xeon as a foundational building block for that, but also continuing to augment it with specialized acceleration in the processor, but then still using acceleration to achieve those performance metrics that we know are so crucial. And then software capabilities like FlexRAN make it possible for us to run those really high performance, very stringent workloads, L1 baseband processing on general purpose processors, whereas historically, in traditional RAN deployments, those are run on custom solutions. And so they really are different architectures and different deployment models, but both equally important to invest in over the coming years.
And then you have to facilitate smooth, seamless transition to the extent it is possible when operators are ready to move from legacy to the new architectures as well, right? So
Exactly.
good. So you mentioned about the complex workloads, especially when you look at 5G as such. Xeons are very powerful processors. You also need different kinds of processors like
Mm-hmm.
FPGAs. You need interconnects, Ethernet cards, and everything as well. So do you see a need for accelerators as well, specifically for radio functions which are very latency sensitive and so on, especially when 5G goes beyond these mobile broadband applications to say mission critical massive IoT use cases and so on. You need a full array of different processors with different capabilities, right?
Yeah, and this really it's really key. This is what I was referring to when I was speaking about workload and use case diversity, is that really what you need is a heterogeneous approach to processing technologies to ensure that you're meeting the needs of those different workloads as well. And so if you look specifically at the 5G workflows that you were talking about, right? Our strategy has really been to take a, high performance but also highly flexible and programmable CPU, optimize that wherever possible for networking workloads, but also complement them with specialized accelerators wherever appropriate. So if you take a look at, one of the most critical, I mentioned FlexRAN before, right? FlexRAN is all about how do you run, layer one baseband processing in software on a CPU, on a, general purpose processor. So if you take, this L1 baseband pipeline, it's a combination of both vectorized byte level operations as well as some very specific bit level fixed function algorithms. Some examples include turbo encode and decode, and also your FFTs. And so if you look at then how you might best process those different types of the pipeline, those byte level vectorized operations have been serviced in the past with DSPs and other processing architectures like that. But then when you look at, okay, how does this happen on Xeon? Well, what we've done is we've actually added new instructions to AVX 512 in the 3rd-gen Xeon Scalable product, and we can tackle this part of the pipeline with general purpose processors with far greater performance. That's what's able to hit that, that 2x in massive MIMO throughput that I was talking about before. But then you have to pair that then with something to run the fixed function operations. And those are very well known operations, very well known hardened algorithms. And so they really don't benefit from flexibility of software. They're more efficient in an accelerator. And so what we've done is we've taken things like turbo encode, decode, forward error correction, and we've enabled those in FPGA and EASIC based solutions. And so it's really the pairing of the Xeon based solution with optimized instruction sets and sometimes integrated accelerators, and then also these additional accelerators in order to provide the best in class performance for that layer one baseband pipeline. And so then what you hit on was then flexibility, right? The need for networks to support anything from 3G to 4G to 5G. You start getting into, supporting massive MIMO. And like you were saying, different use cases across enhanced mobile broadband, massive IoT, and various other types of capabilities. You need flexibility, but you also need high performance and high precision. And so it's really important to actually have a general purpose approach because you can get more scale out of that.
Yeah. Power consumption is another critical factor for any processors for that matter. Any numbers in terms of this 3rd-gen Xeons in terms of power consumption for same workload versus the previous generation?
Yeah, so I think as far as VRAM goes, that doubling of performance within a similar power envelope is certainly an achievement that we're really proud of with this product line. It is really the combination of what we're able to achieve in the processor, but then the overall optimizations in the platform as well, innovations that come from our processing technology, our accelerators, and also our connectivity technology, and then also having that scale across a number of different SKUs in the portfolio. I mentioned the N SKUs, but another product that I wanted to mention that we announced as part of our big event earlier this week is that we will be later this year expected to have production qualification for the next generation in our D line of Xeon processors. Our Xeon D will be based on an Ice Lake processor as well. And what that enables us to do is not only offer higher power efficiency, but also a higher level of integration of IO and acceleration capabilities to support even more stringent requirements, both in the network and edge. So that's something just to kind of whet your appetite a little bit for things that are coming down the road.
Okay. Okay, now moving on to the edge cloud. I think a lot of the edge cloud needs are being driven by 5G and spread of 5G. What are some of the use cases that you're saying from your vantage point that will definitely need a robust edge cloud deployment?
Yeah. And I agree with you completely. 5G is a catalyst for the edge, but the edge isn't waiting for 5G either. And, realistically, there's been a lot of exciting development happening on the edge with 4G capabilities, and we expect that momentum to continue and really new exciting use cases to get unlocked with 5G as well. If you look at some of the capabilities that exist in the network edge today, CDNs, content delivery networks, are actually, very often kind of an under-heralded edge workload, but it really was kind of the original, edge killer app, so to speak. And this has been an area that we've been focusing on as well in terms of partnering with the operators of those CDNs in order to optimize their performance. And for us, it's not just about the processing capability and overall throughput in order to deliver higher performance, but also providing the right memory and storage capability that's so crucial when you're talking about caching technology. And so what we're able to see actually in our 3rd-gen Xeon Scalable products is to actually get over 60% gen on gen performance increase, throughput improvements, and over a third more memory capacity when they're using Optane persistent memory. So it's really, again, that combination of the different platform ingredients, Xeon with the Optane persistent memory, that's able to achieve improvements there for that really critical edge workload. But then if we keep an eye on the future and we think about some of the new use cases that will be rolling out over the course of the next several years, really the best place that I like to look at for where the edge is going to happen, it's where the intersection of compute plus connectivity yields the most benefits. Because the edge is really about how do I bring compute closer to where data is ingested and then also where services are delivered. And so when you look at where the near term pull is coming across a number of different domains, it's in manufacturing in areas like, defect detection and quality inspections and worker tracking. It's in areas like energy and utilities, whether it's mining, whether it's oil and gas exploration, whether it's smart grids, it's smart agriculture, which is an interesting, problem statement when you think about the ability to cover a large area with connectivity and then be able to instrument sensors and then be able to provide real-time and localized analytics based on data coming in from that sensors to improve, crop yield and other areas of focus in agriculture. It's areas like transportation and logistics, like improving capabilities in warehouses and shipping ports, whether it's AGVs and autonomous robots, whether it's inspection capabilities, again tracking human capital as well. And so there's a ton of exciting innovations that are happening both in the across a variety of edge verticals in order to take advantage of the capabilities that are going to be coming across a number of different use case domains in the intersection of 5G and edge.
Yeah, so the mention of CDN is interesting. People never think of it that way, right? I mean, there are a lot of this discussion on exotic use cases, some of you mentioned, which are private cloud kind of applications, be it mining or something else.
Well, we do think of the edge really across a couple different areas, right? We think about it as the edge that's happening in the network, right? So what's happening within the operator network, also within regional cloud deployments from hyperscalers, but then also what's happening on prem. And being able to stitch those together in a way that reflects and takes advantage of the possibility of cloud technology is really crucial.
Yeah, true. So, keeping the private networks aside, if you take a public network like the operator network, I'm a little bit curious on how the topology of this edge cloud is going to look like. Is every cell site going to be an edge cloud kind of a thing, or is it like tens of BTSs or cell sites together? You have a edge cloud serving them, or it's like a couple of them for a city. How is the topology look like? I mean, it's still very early times for it. Do you have a sense of how things are evolving, or?
Yeah, I mean, there are so many different edges.
Yeah.
That's kind of what's exciting about it, right? And so I think we've got an opportunity to deliver, edge capabilities. Some of it will come, from the RAN eventually. I think when you look at traditional base station deployments, it won't happen in the immediate term. We certainly see early trials that we've, in deployments that we've had a hand in terms of deploying edge compute capacity, both in macro and small cell deployments in a number of different functions, whether it's smart city applications or other types of use cases that require broad coverage. But what I would say is that it's really the virtualized RAN deployments and the ORAN based deployments where you start to see then the intersection of that compute capacity and the networking and connectivity capability. Where we probably see, in addition to the use cases that I mentioned that serve a broader customer base or a municipality or a business base, a lot of the initial workloads that are housed at a base station site are really going to be about improving the operational efficiency of the network itself. So it's really going to be areas like network and radio analytics to optimize. Massive MIMO, is a very complex and challenging set of technologies to manage, and so being able to improve that with analytics capability, that's where you can take advantage of edge computing that benefits the operator itself, and then you start to see the introduction of AI capabilities to do that, and then from there you'll start to layer on additional edge services beyond the network services themselves. And so again, I think as we'll see that as that growth rate in vRAN and ORAN capabilities start to roll out, that's when you'll start to see more and more of the convergence of additional edge services.
And that's pretty interesting. So you're saying that it's like one layer of network services, edge cloud. It's needed for the actual working of the network itself, RAN, for example. And then there'll be another layer of
Mm-hmm.
edge for services other than network services, right? Applications and such.
Yeah, because if you think about it, the power of bringing compute closer to the data and closer to where the services are generated, it does, I mean, AI is a critical enabler for that, right? And so if you look at, again, that opportunity to optimize the network itself first, well, what you're doing is you're fundamentally deploying critical baseline building blocks to solve those network problems. Well, guess what? They're a lot of the same building blocks that you need in order to provide those insights for other types of services as well. And so that's where, again, the power of, an open ecosystem based on standards like what ORAN is focused on enabling, and virtualized and server-based technology as part of vRAN are focused on enabling. That's where you start to open the possibility for these types of outcomes.
Yeah, true. So you mentioned about hardware and software acceleration and innovation. Competitively speaking, especially when you look at edge cloud space, as I mentioned, it is power and space constrained. I mean, there is competition, right? If you take, for
Mm-hmm.
example, ARM, whose heritage has been from the low power compute side, trying to get into the networking space specifically for edge cloud. Any comments on how you want to counter or what your strategies are, how you're working towards those and such?
Yeah, low power compute is certainly crucial. In a number of different edge locations, and so there are, as I've spoken to a couple examples, many different design points that we're required to address, and that we hear from our customers every day. But what we're seeing over time is the edge is getting thicker. As more services get deployed, you actually need more compute, and also different types of again acceleration capabilities in order to support that. And what we're actually seeing is that customers are coming to us and they're saying, hey, here are my requirements today, but how do I future proof this? How do I essentially provision the system that I want to be able to deploy today in 2020 for types of use cases that I don't even know yet will exist out in several years down the road, 2024, 25, 26. And so essentially what they're doing is they're building that headroom into their designs. And so when we look at, I talked a little bit about our Xeon D product line for 3rd-Gen Xeon Scalable, as well as the processors that we launched earlier this week. When we look at the diversity of that portfolio, what we hear from our customers is that they value the fact that we've got that scalability from the highest performance down to lower, more power constrained and types of integrated design points. And what we're seeing, as I mentioned before, there are lots of edges out there. So there are, very low end edges, and then there are, kind of mid range as well as very high end. And so wherever our customers and partners are also able to amortize their software investment in a cloud environment and be able to scale those across a number of different types of platforms and design points, that's also an overall TCO benefit.
Yeah, true. There are different kinds of edges, right? Sometimes the edge could be terminal itself in the device itself. Edge doesn't mean it's a computer sitting somewhere away, right?
Right. Exactly.
Okay, so another topology question, and it's more technical as well as business one, is if you look, in the recent history, specific operators are working with specific cloud providers on a kind of a one-on-one relationship. A lot of times it could be exclusive as well. I mean, that's one way, but that may or may not be very efficient.
Hmm.
That if you are with one operator, you have only access to that one cloud that they're working. How do you see that evolving in the future? Like, is it going to be a multi-cloud, multi-party kind of a arrangement? Obviously, that brings a lot of complications. Will it be based on like geography? Will it be based on business relationship between the operators and the cloud providers and the application providers? Any ideas there?
I think all the options that you mentioned are true. And yeah, I think we've talked through so many challenges in this discussion that it's certainly true that we don't shy away from challenges. So I just look at this as, yet another opportunity for us to collectively tackle. If you look at multi-cloud, I think none of us would see it as a surprise. It really is, kind of a natural evolution from where we started with cloud computing, and then where we
Hmm.
went with hybrid cloud, right? Being able to support, kind of on-prem and then centralized cloud workloads and migration between the two, and then now being able to support multi-cloud. And multi-cloud is super crucial as an edge problem statement. It's super crucial as a general enterprise problem statement, but it's especially critical at the edge. And so when you look at what edge cloud really is, it is about trying to, bring the value of the cloud to many, many more locations than in which it previously existed. It's really a distributed computing problem, really, at the end of the day. Right. And as we all know, the distributed computing is not, an easy set of challenges to address. But now we're at a point where, it's an imperative, right, to be able to ensure that edge can be deployed. And so this means being able to understand service availability in, various different locations, whether it's in one cloud or a different type of cloud. There are also, heterogeneous clouds in terms of different types of compute technologies, whether it's, GPUs, CPUs, AI accelerators, media acceleration, different analytics capabilities. You need to be able to understand what the TCO implications are of distributed computing. It's very different than in a hyperscale cloud computing type of environment, but you still need to make sure that the TCO math works out in order for it to be, cost effective to make those services make sense. And then, of course, you've got to be able to solve a
Hmm.
number of performance considerations. There are certain workloads that are going to have, and use cases that are going to have affinity to being deployed in an edge type of environment, but then you need to make sure that you're able to guarantee the quality of service that's expected. And then where you do need interaction with a centralized cloud, a placement of that workload as well, that you're meeting the performance characteristics when the data is being transmitted back and forth. And so, so then when you look at, okay, I've got all these complexities of distributed computing that I need to be able to address. One of the key challenges is, how do I manage the orchestration from a technology standpoint, as well as, like you said, from a business standpoint? And so there are a variety of different technologies that have started to emerge. When you look at, something like Kubernetes, it's, I think, the first the first thought that comes to mind with a number of people when you think about the ability to drive, cloud native orchestration and automation. Because, if we're being honest, right, really a lot of what's happening at the edge is all about driving OT transformation, which is all about driving automation and autonomy. And so really you need to make sure the infrastructure supports that level of automation as well. And it's not just anymore about
Hmm.
orchestrating multiple nodes or multiple clusters. Now it's about, how do I orchestrate at a macro level multiple different physical locations, geographically distributed locations. And so, there's a lot of work underway. You certainly see the hyperscalers who are innovating both within their own domains, but they also realize that there does have to be interconnectivity amongst them. So you see, folks like Google Anthos, Microsoft Azure Arc, creating multi-cloud capabilities in their offerings. You see players like Red Hat, with OpenShift, and VMware with Tanzu, and then also other smaller players have been focused on delivering multi-cloud value as well. And then in terms of what Intel is seeking to do is really ensure, frankly, that they all can be successful. And so we continue to innovate, underlying capabilities in order to provide critical plumbing to make this happen. And so one of the capabilities that we've released in openness, which I mentioned before, is something called MCO, or Edge and Multi-Cluster cluster orchestration, which supports things like SD-WAN, application lifecycle management, which are critical across multi-cloud deployments. But you're exactly right that in addition to the technology challenges, solving those business challenges are really crucial as well. And we're already seeing a ton of partnerships across not just the players that I mentioned, but also the operators themselves, the telecom operators, in terms of partnering deeply with the hyperscalers as well as a number of other players to ensure that they're equipped with best-in-class edge technology, to be able to support this wave of next generation use cases that are so exciting.
Yeah, absolutely. I mean, it will be really exciting to see how this whole edge cloud phenomenon unfolds and evolves, right?
Yes, absolutely.
Excellent. Yeah, I think we covered a lot of ground. Any closing comments?
Just that I'm excited to see what's next. That's the most, the best part about inflection points and big events like a launch event that we had an opportunity to go through and kind of celebrate with our partners and customers. Because the most exciting thing is not purely just to launch the technology into the world, but to see what people do with it. So maybe I'll circle back to the tagline that you used at the beginning, which is how wonderful gets done. That truly is what's happening here. This is it's an important aspect of the engine of all of these networking and edge capabilities. But what's most exciting is to see how it comes into realization in deployments out there in the world. So that's what's coming next.
Absolutely. Would love to have you back, discuss on how things are turning out, right?
That'd be great.
Again, congratulations on an excellent announcement. And thank you very much for coming over to our show. It indeed was an interesting conversation.
All right. Thanks so much, Prakash.
All right, folks. That's all we have for now. Hope you found this discussion informative and useful. If you did, please hit that subscribe button down there on whatever platform you're listening this on. Again, I'll be back very soon with another episode, putting light on another interesting subject. Bye bye for now.